Chapter 3. Subtopic 3.2. Periodicity. Hi. Here are learning outcomes for today. Describe the variation in atomic radius when across a period, across the first row of transition elements, and down a group. Define the term of isoelectronic species. Define the first and second ionization energy. Define electronegativity. Explain the acid-base character of oxides of element in period 3. Periodicity. In this subtopic, we will examine some physical properties of the elements that are in the same group and period. The trends. How to explain the trends of periodic table. The first problem is, where do you start measuring? From left or right periodic table? Going up or going down the group? All periodic table trends, influenced by three factors: energy level, shielding or screening effect, effective nuclear charge. Both energy level and screening have an effect on the group, while effective nuclear charge have an effect on a period. Shielding at screening effect. The ability of other electrons, especially inner electrons, to lessen the nuclear attraction on an outer electrons. The electron in inner shells screen or shield the electron in outermost shells from the full effect of the nuclear charge. Nuclear charge. Describe the charge of nucleus that pull electron closer towards it. When the number of protons increase, nuclear charge increase. Therefore, nucleus electron attraction becomes stronger. Effective nuclear charge. Describe the positive charge felt by an outermost electron. The formula for effective nuclear charge is ZAC equal to ZAC minus S, where ZAC represent effective nuclear charge, while ZAC represent the proton number, and S represent the number of inner electron. Let's look at the table provided. The table shows some element from period 3. We can see that as the proton number increase, the effective nuclear charge also increase. Keep in mind, nuclear charge is not equal to effective nuclear charge. The size or radius of atom is difficult to be defined exactly, because the electron cloud has no clear boundary. Therefore, atomic radius is measured by half of the distance between the two nuclei of a diatomic molecule. Factors affecting atomic radius. There are two major factors that affecting the size of atom in the periodic table. Effective nuclear charge and shielding or screening effect. The trend's atomic radius across a period. Atomic radius generally decrease in a period from left to right. For example, when across a period 3, atomic radius decrease from sodium to argon. This is due to the change in effective nuclear charge. Across a period, the proton number increases. Effective nuclear charge increases. Outer electrons are pulled closer to nucleus. Therefore, atomic radius decreases. The trend's atomic radius, down a group. Atomic radius generally increase in a group from top to bottom. For example, when going down group 1, we can see that the atomic radius increase from hydrogen to rubidium. This is due to the change in energy level. When down a group, energy level increases. Shielding effect increases. Outer electrons are further from nucleus. Atomic radius increases. Trend's atomic radius across first row of transition element. The atomic size among transition elements is decrease. But from manganese to copper, they are approximately constant. This is due to the electron are filled to the inner shell, 3d. But the number of electron in 4s orbital remains the same. Increase in nuclear charge is cancelled by the increase in shielding effect. Therefore, radius is not significantly changed. Isoelectronic. Ions or atoms with the same electronic configuration are said to be isoelectronic. Aluminium ion, oxide ion and nitride ion have same number of electrons and electron configuration, so they are isoelectronic. Ionization energy. We can define the first ionization energy as minimum energy required to remove 1 mole of electrons from 1 mole of gaseous atoms, while for second ionization energy is energy required to remove 1 mole of electrons from 1 mole of gaseous ions. Factors affecting the IE. There are 4 factors that affecting the IE, which are energy level, shielding effect, atomic radius, and effective nuclear charge. Both energy level and shielding effect are correlate to explain trends of IE down group, while atomic radius and effective nuclear charge are correlate to explain trends of IE when across a period. The trends of IE down a group. Generally IE decrease down a group. As down a group, atomic size increase due to N increase. shielding effect increase, resulting weaker attraction between nucleus and valence electrons. So, less energy needed to remove valence electron. Therefore, i.e. lower. The trends of IE across a period. Generally IE increase across a period. As across a period, the proton number increase. Atomic size decrease due to effective nuclear charge increase, resulting stronger attraction between nucleus and valence electrons. So, more energy needed to remove valence electron. Therefore, IE higher. Electronegativity. Tendency for an atom to attract electrons to itself when it is chemically combined with another element. Atoms with strong attraction for the bonding electrons have the high electronegativity. For example, hydrogen fluoride molecule. The electrons spend more time closer to fluorine. Fluorine more electronegative than hydrogen. This will cause fluorine ends of the bond partially negative, and hydrogen end partially positive. The highest electronegativity value is 4.0, assigned to fluorine. Generally, atomic size decreases, electronegativity increase. So, we can conclude that electronegativity increase when up a group, and across a period. Element in period 3 are included: sodium, magnesium, aluminium, which are metal, silicon informed of metalloids, while non-metals are phosphorus, sulfur, chlorine and argon. Generally, when the period 3 elements react with oxygen, metal will form basic oxide, non-metal will form acidic oxide. Some metals and many metalloid will form amphoteric oxide. Metal oxides. They are ionic compounds. In water, metal oxide acts as bases, producing hydroxide ion. Metal oxide also able to react with acids. Non-metal oxides. They are covalent compounds. In water, non-metal acts as acids by producing hydronium ion. Non-metal also able to react with bases. Amphoteric oxides. Amphoteric oxides are compound which exhibits both acidic as well as basic characteristics. It reacts with both alkalis as well as acids. The trend in acid-base character is shown in various reactions. But as a simple summary, when across the period 3, the trend is changes from basic oxides to acidic oxide, via an amphoteric oxide in the middle. An amphoteric oxide is one which shows both acidic and basic properties. As a conclusion, students need to know the definition of isoelectronic, first ionization energy, second ionization energy, and electronegativity. Generally, when across a period, atomic radius decrease, ionization energy increase, electronegativity increase. When down a group, atomic radius increase, ionization energy decrease, electronegativity decrease. And when across a period 3, acid-base character of oxides are changes from basic oxide to acidic oxide via amphoteric oxide in the middle.